everyone. So in this particular video and in the upcoming series, we will be exploring about machine learning using Spark. Okay. So Spark is a big data framework. Primarily, it is built on and written in Scala, but you can leverage the features in Python as well as in Java. Spark is a distributed big data processing library that you can use to solve data problem at a scale. Okay, when I say big data, generally, big data refers to a data which cannot be handled by a single compute machine. So something of a scale where your compute cannot be handled by a single computer, you will use distributed computing frameworks, and Spark is one of them. So most of the things are taken care or orchestrated by Yarn or some cluster or some resource manager, which we'll go through later. But the whole idea is that you do a map reduce. There is a concept of map and there is a concept of reduce, and you solve your problem using map reduce, and yeah, all of the things are computed and done in a lazy manner in Spark. Okay. It's a very powerful framework. There are multiple different hierarchies of this libraries. One of them is MLlib. One of them is Spark streaming, where you can play around with the streaming applications. The whole idea of this series is to explore machine learning with big data. The reason why I want to do that, or wanted to explore this, was we know that data can be huge, and we always work with samples and machine learning. But say you want to do or apply machine learning on a scale of data that no, you cannot apply. You tend to select something that is of very huge scale and cannot fit into a computer. What will happen then? So you have to rely on something like a Spark. Obviously, this is there are way more other libraries in the market right now, which are far more popular and are getting used in um in 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 no broadly better way as compared to Spark. But it is good. It is always good to explore the capabilities of such a framework. It has been put under the table, but yeah, let's go through the important features of what can be done through Spark, specifically in the world of machine learning, right? And how can you leverage that, and how can you play around with this? So I will go in this in a very structured manner. So it requires a bit of Scala language understanding. So Scala is a very beautiful language. I will try to cover it as a crash course. If you haven't worked on Scala, it is again a statically typed Java like language, but far lesser verbose and very no semantically and syntactically soothing in its application. So the whole idea, the whole structure would be, I will be trying to go over Scala basics, a bit of a Scala advanced, some of the advanced features of a Scala, and slowly and steadily we will move on to look into basics of a Spark, how Spark is structured, and then start with the machine learning paradigm of Spark. Okay, so let's keep it simple. First, let's go through what we would be covering in uh, overall series. Okay, so you can see here I have created a clear README. I will post all this into my GitHub. You will have to look into my GitHub repo to get into all these artifacts, to download all these artifacts, and I would highly recommend you run it locally. How to run that, we will look into step by step, but the whole idea is that you check this code out, and then um, try to run it is step by step on your computer. Okay. So the whole lot of thing what we'll be covering is basically the installation part, how to run a Scala on your local machine. There there are a set of machine learning algorithms which has been which we'll be seeing and looking into, and trying to get into and understanding how they can be coded end to end. Um, we'll be not going into very detail of it, but still you will be able to understand and correlate how Spark can be used to run different machine learning algorithms. Okay. So as I said, there will be a small crash course of a Scala first, so that gives you a flow of how exactly semantics or the syntax of Spark look like. And once we are done with the basic Scala syntax, we will move on to Spark, and then MLlib part of the Spark. Okay. So this has been structured in the following way. So when you actually check out the code, you will be able to see multiple scripts that can perform different that can run different algorithms inside them. So one of them is run all.sh, that will be able to run all the machine learning algorithms what have been no provided here. It will give you options to run, as well as you can run all of them in one go. Then there is a UI part that basically creates a Flask application that basically you can try to do an interactive collaboration with the machine learning model that gets created. So I have saved these machine learning model at a location. So this is the location, models Python, and inside that you can find the models. So these models are actually the machine learning models that will be referred from the UI when you do actual predictions. Okay. And as I said, there will be a set of different it will be an end to end basics to advanced uh, tutorial around Spark, doing machine learning from Spark, and some basics of big data using Spark. Okay. It is not possible to cover all of them in few hours, but I will try to give as much information as I can, so that it helps you do the setup and run machine learning from scratch on your local machine. Just as a caution, I am using Mac here, but if even if you are using Windows, you are free to no try that out. Most of the things will be as it is. The setup will be as it is, and it will just work just fine. So I have used IntelliJ IDEA as the development environment. This is the version I am using. Okay. 2025.2.4 ultimate version. You can use it as a community version if you if you just want to do development on your local. This is the project structure. As I said, this is mostly related to the big data part, or the machine learning part, but we'll start with basic Scala first, and gets hands on into different features of what Scala provides, and on top of that we will build the different features of machine learning on over the Spark, using different features of the Spark. Okay. So let's start with I will just try to create a Scala playground. Okay. And then we will be trying to look into the semantics of the different aspects of how Scala actually fits into this thing. Okay, just allow me 1 second and I will be back. Yeah. So we'll start with a Scala playground. So the way you can do or create a Scala playground is I will delete it and create it from the scratch. So that gives you a we'll go a bit quick, but with the interest of time. Let's try to create it hands-on. Okay, so I will name it, say, Scala Playground. Okay, and so the whole idea is to introduce you to all the important features of what a Scala can do over what language you already know. So I'm hoping that you are familiar with one of the programming languages. So this is a statically typed language, runs on the JVM. It blends object-oriented programming with functional programming, and it is interoperable with Java, right? So as a JVM language. Basically, the way how we declare variables are of two types. There are two types of variables that can be there in Scala. So the one is called val. So if you write val, say some name, and you assign it a value, okay, and this worksheet compiles and runs and gives you the output feedback immediately. So it has declared a value c, and we have assigned the value 10. So this is one type of variable assignment what we do in Scala. Second type is var, using var. So the above one creates a constant, and this one will create a variable type. So you cannot change the value of c in future aspects, but you do can for val. So these are the two types of variables what we have in Scala. Okay, then basically you can create an app like public static void main, as we used to do in Java, right? So here you can create something called as an object, and that object, if so let me create that. So I will create the first hello world Scala application. So for running it, we create an object generally, okay, and we generally extend the app. So this app is nothing but, if you go inside, it has a main function, okay, that is linked to the main function, def main, okay, which is the JVM starting point, and from there on your execution starts, right? The other way is to, you cannot, you don't want to, extend app, you can just write a main function here, and you can write all your logic here, right? So it's very simple, and as good as no as if you have done coding in Java, it will be looking like similar thing. So if you just write hello world, right, it should just run fine and give you the output. Okay, and you can see here, for this particular project I have used JDK 17, which is mentioned here. When I have configured this project, I have installed JDK 17, which gets used inside when I'm actually calling this hello world app. Okay, and now when we talked about two things: variables, how to run a standalone Scala application. That is the first Scala application what we want to run. Then there are different data types, right? The different data types in Scala are generally as same as Java, but they are int, long, double, float, boolean, char, and string. Okay, these are the primary data types. There are other data types, but these are the primary basic data types what we have in Scala. Okay, and so we build over these data types. So there is a concept of advanced types. Okay, I will just try to, if you are a Java developer or you have developed stuffs in Java, I will just refer you to one of the blogs which I have written earlier, which I will definitely recommend you going to and looking into that. Just allow me 1 second. So if you just go to Medium, right, and if you just go to my list of published stories, okay, um, you will find a lot of good starting points from, if you are transitioning from Java to Scala, okay, or if you want to learn Scala. It's not about transitioning. Everyone is considered to, in this particular time, we are considering everyone to be familiar with so these blogs I have written long back, actually in 2020. Okay, and I would strongly recommend you to go through these blogs. Okay, these talks about how Scala has reduced verbosity from writing big verbose codes in Java to very streamlined and small snippets of Scala, right? And also, not only it's about uh, removing verbosity, it's also about writing more readable code and writing more functional code. We want to get away from side effects from the code as much as we can. That's where Scala comes in handy, and there no Scala plays a big role in helping you reduce side effects and write more functional programming code, focusing more on your business logic. Similarly, I have I will just mention these blocks over to the YouTube video, so you can just go through to just familiarize yourself what these talks about. These talks about how not to get started, but in the meanwhile, as I said, I will cover it as a crash course. Okay, so you don't need to worry much about no even if you're not able to understand these blocks, these some of these concepts are a bit advanced, like these are mathematical and relates to mathematical concepts of monads, monoids, and whatnot, a lot of those semantics. So uh, let let's go back to our scratch pad and uh, complete the Scala crash course. Okay, so we were looking into the data types. Okay, so once that data type is after the data types, and you have created the Scala application, right? Let's move on to control structures. Okay, so in control structures, basically we have loops and if else statements, and they are very similar to how you actually um, do in Java, right? So basically, if you have some, say, age, I define age, say 30, and if you want to add a condition, say if somebody has age greater than 18, right? Then you will say adult. So you can see here, if I directly, I don't have to write explicit returns in Scala. Okay, it gives a lot of flexibility of adding things by itself. So if I print just status here, what gets assigned to status, you will see that it takes this age and applies the if condition, and it prints that it has an adult stored to it. So very much similar, like how we do in Java, right? Then we have loops, right? So say I have to run a for loop, right? So say I want to print number from 1 to 10. Okay, so it's very no there is a lot of syntactic sugar when you actually work with Scala, but I will just tell you how do you cater to all of them. So if I just write this, it will extract this as a list. So this will be extracted as a collection from 1 to 10 values, and it will just pass on these values to this particular print statement, right? And you will be able to see all these number. Obviously, I have not written print ln here, so if I write print ln, it will be all in the new line, right? Or with a space. Fine. This is about loops. Then very important aspect is how to define functions in Scala. Okay. So defining functions is very elegant. So you write something, say def add, uh, then you specify the parameters. You write the function name, then you specify the parameter names. Okay, you specify the types. Okay, and then finally you give the return type. Okay, after the colon you will say the return type, and the implementation follows, right? Fine. So this is how you define a function. So it's a single line function. So I haven't used braces here, but if you are writing a multi-line function, you should be adding a practice to actually write it in the curly braces. Okay. So you will write complex functions as curly braces. So this is how you define the parameters. There is a way to basically add default parameters. So suppose I always want to assign this value of num1 to be 10. Okay, so you, even if you don't assign this, it will be acting as a default value. This is the concept of default value in Scala. So even if you just pass in and call this add function, okay, num2, this is calling by parameter. So if I add 10, so it will not complain, and it will just return 10 plus 10 20. Okay, you can see here it is not complaining about that it has not given the first parameter. It has just taken it as the default what you have given here. So this is how you default your parameters in Scala. Coming very quickly to collections. Okay, in collections generally we use lists. Okay, so say list one, it's very simple. These are immutable lists. Okay, if you, there is a provision to create mutable lists as well, but this is how you basically create a list. So there is a concept of monad. So monad is a wrapper of a type. Something wrapped over is called a monad. So list is a type of monad. Okay, so something can be wrapped over inside list. So there is a data type, and then there is another data type which is basically the integer. So this is basically a list of integer, right? These types of structures are called monads. Okay, and monads generally have two things. One is map and one is flat map. It has an empty function as well, but mostly we care about map, flat map, because we will be working on to a big data machine learning type of a setup. So there we will be more of concerned about the mapping part, how the mapping happens. So basically the idea is that over a monad, you can basically apply a map and ask it to do something like this. So the underscore mentions that each of the elements of this list will be incremented by 2. So ideally I'm expecting the same list number, but this will be again mapped over to plus 2. So 1 will become 3, 2 will become 4, 3 will become 5, and so on and so forth. So this is how the mapping operation works. And so map and flat map are available to all monadic functions what we have in Scala. Okay, then we have lists, we have tuples. Okay, there are multiple other functions, as I said, list. Then you have list dot filter. Okay, underscore. So this will have to be a Boolean expression. Okay, so if I do this, this will only give me the even numbers, because this is a condition where if the divisibility is true, divided by 2 is equal to 0, then it will keep that elements to the list, otherwise it will filter. Similarly, we have other functions like reduce and all, which you can see and explore, but we'll just move on with other aspects of collections. So there, as I said, there is a concept of tuple, which is very important. Um, so how do we define a tuple in Scala is something like num1, say, or 4, 5. Okay, so this is a tuple, say val. Okay, so this is a tuple, and how do you access it? So basically you have to just do tuple underscore 1, then tuple. So this is how you actually access the members from the from the tuple collection. Okay, So these are the basic data structures, which will be very handy when we actually do Spark in detail. There is a concept of classes. How do we define classes? Uh, so in Java, we used to create a class using class keyword. So here we generally tend to use a word called case class. So say I am creating a case class, say vehicle, and you can give different attributes. I say vehicle ID, um, int, and say model, give the type. Okay, this is how you create a type called um case class. Okay, there is a concept of creating objects. So object is a singleton type created from the case class. So if you create the same entity with using object, that creates a singleton instance of that particular entity, whatever you have created. And you can use a lot of other semantics on no the companion object, or you can say the singleton object that has been created. You can explore more about it. Now, one of the important aspects, what is worth talking about is basically pattern matching. This is a very core Scala skill that everyone should basically have. So pattern matching is like uh, a list of cases what you need to match on, and it works like a lot of different versions, or you can say formats. It's not only that a single it's a single case, or a particular type of a case that you are trying to match. There are multiple versions what you can create of pattern matching. Okay, so one of the versions is this one. Okay, so say you want to pass in anything. Any is a type in Scala. Okay, so it talks about that any object can be assigned, any type can be assigned inside this, and basis on the type, whether it's an integer, string, or anything, like it will try to know match it using the different cases we have. So the idea is simple. You have to write the cases, different cases, and after the cases you have to basically specify what actions needs to be done there for each of the cases. Okay, so you can directly call it, right? Using say I'm passing a string here, so this should return me this particular thing. Okay, let's see, I'll run this again in the playground. Okay, yeah, this returns you the string. So I'm just thinking what more is remaining now. So we have covered a lot of the important basic stuffs what we will use in Spark. Now there are some functional functional programming stuffs, like functional programming stuffs, which is very important to understand. So suppose you want to use higher order functions. There is a concept of higher order functions in Scala. Okay, and in higher order functions, basically you pass in another functions using the function anonymous function inside a function. Okay, so just for an example, say I want to apply a function twice onto a given value. Okay, so say I have created a function def apply twice, right, to a given function. I will take two parameters. So one will be the function itself, and then x. So okay, um, and this will return an int again. And what I need to do, so this is the f is the function. Okay, and I have passed into another function called apply twice, and I want to apply this over x. So x one time application will be f, Okay, and then another time application will be over f, right? This is apply twice. So this is how basically this works. So say I pass on, for an example, anything given will be incremented by 1. This is the function, okay, and then I pass in 5. So ideally this should give me 5 plus 1 plus 1, that is 6 for 7, right? Let's see, it gives you 7, correct? So these are some of the syntactic things, and a bit tricky, but if you understand it, it will become very easy. And then as I was talking about the monad thing, right? The monad, how Scala works with monads. So there is a concept called um there's a concept called option in Scala, right? So anything you create as an option has two values, some or none. Okay, so say I create something as 5. So this means that this type can, it's basically an option. It is a data type that prevents you from null pointer exceptions. So it wraps it, if there is some value it will wrap it to some, and if not it will wrap it to none. Okay, so let's try to do some exception here, maybe uh, or let's do one thing. So I will just go and show you how this is structured. So this is an option class, the option type basically, and it has two different, it can take two different values, some of it and none of it. So if there is no value, it will wrap over to none, and if there are some values it will wrap onto some. Okay, then you have error handling. How do you handle errors in basic Scala? So how do you do that? Is basically you if something is divisible by 0, it will give a mathematics runtime exception, right? Divide by 0 is not possible. So basically there are few classes that take care of this handling, and this is again a trimonad, and you can match. So I was telling you that there are versions of um, multiple versions of case match possible, and you can see one of the examples here, like result is trimonad. Okay, it will be having some value that will be returned out of this computation, and this will be stored here, and we are trying to match it. So when you actually try to see what try can return, okay, so basically it returns a success or a failure. um, okay, there is a success type. Okay, and similarly there is another type called failure, right? And it will return one of these when you actually this is the type. Okay, so one is the failure, and one is the success, and it will return one of you when you do that. So when I run this, basically you can see that it has caught in the failure. Okay, it's an arithmetic exception, division by 0, and that is not possible, and that has been caught up inside this try catch handling. Okay, there is a concept of immutable and pure functions in Scala, right? Pure functions are something where you don't have side effects. Whatever computation you do, that basically translates into the method, and nothing else happens inside that method. And then you should be aware of a bit of futures. Okay, like a future is nothing but basically something that gets completed in a future time. That's called future in Scala, and that's how you handle the future threads. Okay, this gets complete. You can call a lot of functions on futures to make sure that no, it has completed and you get the value in the future time. This is how you do asynchronous computations in a Scala. Okay. So we have covered a lot of things. There is a keyword called implicit in Scala, right? um, so there is a keyword called implicit. So implicit is like you will try to create something that basically is there in the context. So it is just like a hidden value. It will be not be visible, and you will be still be able to try to use these values inside in the code what you have. We'll try to show when we actually do some Spark related computations, and how do we use implicits. There's a we have seen the for loops above, right? But there are other ways to write for loops, right? You can write for loops as this. So you can write an yield here, right? A for loop here. Inside this you will do a lot of, so this is basically a combination of map and a flat map, okay, internally. And this converts and computes the value of sum of none. This gets mapped and flat mapped to a value, and finally you get the computed result as a plus b. uh, this is it. I think we have covered a lot of stuffs here related to Scala, right? Basics of a Scala, and we can at least get familiarize ourselves with uh, what will be actually needed for a Spark computation, right? Now let's go on to Spark thingy, okay? And there are some important concepts in a Spark, right? Um, okay, before we get into Spark, I just want to make yourself familiar with some big data semantics. Okay, let me try to see if I can open it. Okay, so I will try to show you from any diagram which is available, and then we can get started with other code related stuff. Okay, so I will just start. I will just ping on any diagram what I see, and we'll try to explain how actually the architecture looks like. Okay, so this is from one of the trusted sources, so we can utilize this to explain this. So you can see here, right? The Spark, basically the concept, as I told you, basically what it does, it does the distributed data processing. There is a driver program and there is an executor. So there is a driver that takes care or orchestrates. There is a cluster manager that orchestrates the flow, the connection between the driver and the executor, and the switching happens. So there are some tasks that gets divided into the worker nodes, or the executors processes them, and then all of them are merged back and sent on to the driver to consolidate and make sense out of it. Okay, and it's very simple basically. No big jargon here. So basically the idea is that we'll do computed the computation in distributed data, distributed machines. So why we are preferring Scala here, right? The reason to prefer Scala is because it favors mutability, non-mutability. Okay, the when you read lots of uh, blogs, the suggestions, and all those given by big architects, or even the founder Martin Odresky have done his course on Scala from Coursera, and that talks about that most of the Scala developers favor to write code using the non-mutability paradigm. The reason is, when you write non-mutable code, the reason for it to be getting changed, or the states getting changed, is very low. And when the states get changed lesser, the chances of getting modified, the state getting modified, or getting it distributed is far more easy. Like, so you can distribute that same code over multiple nodes, and all nodes can process the states independently, and then results can be combined back to a single node after the computation is done, right? So that is why Scala was preferred due to its non-mutability paradigm, and obviously the functional nature. It allows you to write a lot of map reduce in a functional form, which we'll see in coming time. So we'll just go through some basic concepts of Spark. I'm not sure if I have placed it here, but there are some basic data structures that basically Spark has, right? The basic data structures are RDDs, resilient distributed data sets, and there is a data frame, there is a data set. So there are three different ways in which you can write your Scala program, and there are three different data structures what you can use to write your Scala program. And there is a big difference, not very big difference, but yeah, I would say you should be very clear on when to use what. So resilient distributed data set, that is RDD, that is a low level distributed data structure. Okay. um, uh, that is basically a collection of objects spread across the cluster. It has not got schema, and it is not very optimized, but it's, as I said, it's a uh, low level distributed data structure that is used in Spark. So how do you create an RDD in general is, you basically do something like this. Okay. We'll need to create a Spark session here, to basically make it work. But the idea here is that you have to create a RDD. Okay. So if you go to any of the examples, right? So this is how you basically create a Spark session. Okay. If you just paste it here, it will just work. And you just need to do some imports and do import some configurations. This is the configuration for the machine. So right now I'm running on my local, and when you will actually run on your server or an Amazon MapReduce, you will change it to the actual master. So we were talking about RDDs. So RDDs are basically, as I said, they are low level distributed data structure. It has not got schema, but this is how you create an RDD, right? So basically an RDD is one of the ways in which you represent the data. So if you have uh, any data, so here you can see I have used the list, right? But you can have a CSV result that needs to be processed. So any of those stuffs can be loaded as part of RDDs. Okay. Then the second thing, so where you will use this is where you will require a low level transformation, complex unstructured data, and legacy Spark code, right? There you will use the RDD. Second thing is the data frame, right? The data frame is the high level abstraction, distributed table with rows and columns. So it works like if you want to work like SQL like setup, you will use the data frames, right? And there you have a concept of schema where you can create a schema for your entities. How you do that is basically like this, right? So you create a data frame. So again, to reiterate, this was RDD, the first one. This one RDD, this is resilient distributed data set. This is DF. This is data frame. So this has taken two records, right? Again, you can have your CSV here, and then it is trying to call API called 2DF, and 2DF basically takes some columns and creates that to a data frame, right? And finally, there is a concept of data set. Okay. And data set is more type safe. It is wrapped onto a type, right? and this is how you create a data set. Okay, data set. So we have to create a type here, right? Once you create the type, you actually bind that type to the data set. Okay, so the data sets is basically bind or tied more towards the Scala entities, and it works fantastically well, as compared to the other two which I mentioned above. Okay. So when to use when, right? As I mentioned earlier, right? RDD have low abstraction level. It hasn't got a schema. RDD are type safe. They are not optimized. Data frames are high abstraction level. The schema we have, yes, and there is no type safety in data frame. It is optimized, and data set is basically high abstraction level. Uh, with a lot of type safety, right? So these are the different data types. Okay, what we have in Spark. Okay, so you can semantically solve your problem using these three different conventions, either using data frames, data sets, or RDDs. Okay, now moving on to the next step is going through the readme again. Let's see how much of it is we have read. So we have covered basic Scala. Okay, that is essential for the Spark and the ML part, what we'll be doing. And then we have now got understanding of the basic data types of no Spark. So let's run the Spark fundamentals job, and let's go one by one what it does, and we'll just try to walk through very quickly to understand some basics of the logic step by step of the Spark fundamentals, which is the first section for starting the Spark related concepts. So, as I have mentioned earlier, the Spark related we need to always create a Spark session, that is the entry point to the to be using a Spark. So that takes some configuration. You have to provide an app name, you have to provide a master, and as I said, as I'm looking locally, there is a way to replace it for your local, that is local. Inside bracket you will write star config. It's basically true here, right? So I have enabled some of these configurations, but you can leave it. It doesn't matter as of now. So we just want to test some of the very basic features what we have in Spark. Okay, we'll start from here. So to run any of the RDD related stuffs, you will need to import this spark.implicits. Okay, we'll come to more detail later. As of now, you just need to import it into the context so that your command runs fine. Okay, compile fine, and is able to pick up the context into the runtime when and actually the program compiles. Uh, we'll start with the RDD basics into the code. As I said, RDD is the low level data structure, and which is Spark prefers. It basically wraps that Spark session what you have created, and you if you pass in any collection or a file into that into your Spark session, it converts that to an RDD. Okay, so if this numbers is an RDD, how to check that? So you can double click number and then option enter for me, and alt enter in Windows. Okay, it will ask you to create a type annotation, and you can just create the type annotation for this variable, and that is basically RDD of this particular stream what we have, right? So this RDD gets created inside the numbers. Then we have a lot of so we want to first print this what exactly this RDD, or what's there inside this RDD. So you can print that using the first take function. So as of now, it doesn't gets to any action. Okay, so Spark does a lazy evaluation unless and until there is a action triggered onto the Spark. There is uh, no execution, or no actually compute that happens inside the Spark framework. Okay, so on this data frame, on this RDD, you can call in whatever functions you have. So we went through a monad data type. This is again a type of a monad in which you can call map, flat map, filter, and whatnot. Like a lot of operations you can do onto this, and you can think of it as a stream of numbers, or a stream of wrapped RDD monad wrapped entities, and you can perform all your computations. And finally, when you are done computing, you can actually trigger an action function, and when you actually trigger the action, it actually results and give you, it actually triggers the action and runs the whole DAG execution for that. Okay, similarly, we have we can do a lot of other operations onto your RDD, and we'll see the output, how it looks like. Okay, so that is about RDD. So one of the examples I've taken is for text. So there is a bunch of text, and I want to convert that to lowercase, and then find out the maximum used, or the maximum frequency words. Okay, uh, that we have inside these set of texts. Okay, so you can find that using Spark, using the semantics, what I just explained. So will you will take convert that to an RDD using the Spark session, and then you use flat map, combination of flat map, and then you will map the words to a lowercase using the map, and then reduce it by adding, and then sorting it basis on sorting it in the descending order. That will give you the number of counts, what how many times a particular word is occurring inside a particular in the whole list of sentences what we have passed in, right? Then similarly, as I mentioned, data frame is more refined. You can have a type to it. Okay, there is a, you can add a type. Like here I have specified a person type. So person is a case class. We understood about case class, that case class is nothing but basically it's a normal Java class with some special features, like it creates the getter, setters, and equals, hash code, and all those things automatically, right? So it is wrapped to a type, and then after wrapping to a type, basically we have created a set of sequence inside the person, and yeah, this is basically a type of, let's look into the type. So this is a sequence. Okay, this is an sequence of person, and then we have taken the sequence of person and converted to the data frame using the 2df function. So you can convert that using a 2df library, using the 2df which is inside the Spark library, right? And then you can print the schema. So this has wrapped this to a data frame schema, and then you can do all those computations, all those different queries and semantics operations what we do in Spark, what you actually do in SQL using this data frame. Okay, not very complex, but yeah, it covers how actually you can wrap the data frames into your data into data frames and RDDs, right? Let's run this and see how it looks like. So I have created a configuration for this. We'll just look into and show you once. So I'm using Java 11 here, basis on the Spark version. I have tested that with Java 11, and you just need to configure that in your launcher, and once you are done, you can just click on run, And once you run this, you will see some logs. Okay, you let it run, and then we'll go through the logs one by one. So these are some of the comments, right? So you can see it has founded the frequency of words in the decreasing order, right? Using the text semantics, what we did, using the text computation, what we did. Similarly, we have this schema for the data frame example, what we took, right? And data frame content, it is showing as in the schema format what all different objects we have inside the object of the data frame. So yeah, I think this is the starting point of what we want to. So we had a look into a lot of things. Just a recap of what we did. Okay, we started with the basics, what we want to do. So the end goal is to go to machine learning. Okay, understand how machine learning works with Spark. So we started with basics of Scala, right? Basics of Scala. We started with basics of variables, different data types, how to use for comprehension, different types of case matches and all, and different types of collections inside Scala, and how do you do the no. Use of the different types of case match treatment in Scala and all those. And then we started with basics of a Spark, right? Where we understood about the data, different data structures what we have. The first thing is the basic one, which is the RDD. Then we have more advanced one, that is data frame, and then we have data sets, which will be looking into the next video. I hope you are finding this useful. Do leave me a feedback if you think I should take care of some of the aspects. But the whole idea is to familiarize everyone with all the basics of Spark, Scala first, and then dive deep into the machine learning aspect of the Spark library. Okay, so we'll touch base on to the README again, and we'll end the session. So we have started with basic Scala, and basic Scala we have covered. Basic Spark we started, like setup, Spark session, RDDs, lazy evaluation, data frames, and SQL. We gave some basic implementation. Then now we'll be moving more towards data processing analytics, then feature engineering, classification pipeline. So these are the different machine learning pipelines which will be built going forward, right? Hyperparameter tuning, clustering, and recommendation system which will build, a lot to come, right? And it will be having a few parts, as I said, part 1, part 2, part 3. Probably I will try to cover in 3 to 5 parts. But yeah, stay tuned. I think this will be very useful, and very applicable to big data using machine learning. Okay, thank you. See you soon. Bye.